Thank you. I hope it's really a delight to be here. I'm excited to share my work. I'll try to make it fun and entertaining, but also useful. And I'm just going to start with a caveat that this work is ongoing. We're not done, and so you're seeing things that are. I'm going to share with you things that are hot off the press or not even at the press yet. The first thing is I want to be very clear that my work, I've gotten a lot of help, and these are kind of the team that has come together for the ideas that you're going to see here in various configurations. And what that really means is that if you see anything you disagree with or anything like that, you now know who to blame. So I really want to convey a meta point, and this should not be controversial. It's at least the first thing when we talk about the reliability crisis, and the first is that claims only justifiable claims will be reliable, and the second part is a little bit more. A little bit less straightforward in how we think about it and how we use our statistics, but I'm also going to make the claim that most frequency statistics or claims based on frequency statistics, and I'm foreshadowing a little bit, I will explain why a frequency statistic is a claim by definition, are not justifiable. But first I want to do a little example. And this is an example of reasoning in practice. And I'm sure you're all familiar with this scenario. You ring your friend's doorbell and there's no answer. That's your data. And then you have potential explanations for this. So the first explanation is your friend has gone paranoid and thinks there are enemy agents ringing the doorbell. The second is your friend suddenly has lost their hearing. The third explanation is your friend moved, and the fourth explanation is your friend isn't at home. And so we can reason about these explanations. So the first one, we're going to bring our prior theory and our judgment to bear on thinking these things through. And while it's pretty rare for people to have psychotic episodes, so that we're going to think of that as a very rare event. Suddenly losing your hearing, it can happen, but it is also very rare. People don't move that often, that's rare. And then maybe your friend's not home, maybe that's likely, maybe your friend is flaky, something like that. And you can think about how you would collect more data to evaluate each of these hypotheses. So if your friend's sick, you might call their relative. If you think they've lost their hearing, maybe you're going to shine a flashlight through the window to grab their attention. If they move, maybe you pick up your phone and you check the email for an announcement. If they're not home, maybe what you do is you call them, or you kind of peek inside the house, something like that. So given that this is more likely, this might be your strategy, your research strategy. Right? And so here you go, you're going to call, you're a little bit annoyed. And looks like the explanation is twofold. One, your friend was asleep. The other thing, you were at the wrong house. And when you actually started paying attention. So the first thing to note is that these two other explanations were things which for every reason you hadn't considered. And I don't know, but you may not have thought of these instantly as I presented my four explanations, but you can also think about how this might cohere with prior theory. Your friend is sleeping, well, it's noon. So that's actually additional information as well. And you might think you might be at the wrong house because you're you and you're not very good at things like that. Now notice when you get this additional information, when you called and looked inside, you can probably eliminate these two things because your friend answered. And so clearly they're not agents and they're not deaf, but you don't actually know if your friend has moved. right? And you don't actually know if your friend's not home. All you know that they called, they answered, and you looked in the house and this is the wrong house, right? So that would lead you to even more data to try to figure out which one is the right explanation. So this sort of reasoning is called inference to the best explanation or abduction. And you start with the evidence. Here's something that needs to be explained, sometimes very specific, sometimes it's general. You consider potential explanations, and then you choose the best one, right? And then the explanation may have additional consequence, or implications, and then you go into the data and you try to explain more about that. And then when you go into the data, and we'll get to this later, you'll come to some sort of judgment about what might be best. So with that background, I'm going to make two claims and one conjecture. And so the first half of my talk is really going to be about justifying these claims. And the second part is going to be about exploring the conjecture. So the first claim is that empirical papers in strategy are almost always abductive. And I think that recognizing this will help us attenuate the reliability crisis. And then if we write how we reason, then I'm going to argue this is going to lead to a much more productive discourse. So I'm going to unpack each of these as we go forward. But before I do that, we're going to do a little detour into modes of inference. There's some really basic philosophy of science things. I'm sorry if you're already familiar with this, but I think it's very helpful to clarify, because I have noticed, at least in strategy, but I think also in OB, the way we use the terms deduction, induction, and for that matter, even abduction, are not entirely consistent with what you might learn in a philosophy of science class. So I wanted to go back to those basics and talk about that. So deduction means that we derive a conclusion from the premises. And I'm just going to highlight here that there's no uncertainty in a deductive claim. This is the 2 + 2 = 4 sort of idea. So as an example, and you can find this example all over any philosophy of science textbook, all humans are mortal. That's a premise, prior theory. Socrates is human, and that's a data observation, but also a premise. And if these two things are true, then Socrates is mortal. That's a conclusion. It follows from the two premises. So that would be a deductive claim. But there could also be an inductive claim, and this is from the specific to the general. So we're going to say Socrates is human, and that's a premise. And here's the data. Socrates is mortal, and that's a premise or prior theory. And then we're going to conclude all humans are mortal. And in essence, this is a hypothesis. We don't really know this based on this inductive logic. Instead, and this is a general problem in almost all of our inference, because we are almost always making generalizations from whatever sample or data we have. So in this sense, all empirical research must be inductive. So this isn't a new idea. This is David Hume's problem of induction. And Hume noticed several centuries ago that almost everything we believe about the world is a form of inductive inference. And kind of the hyperbolic example of this, which is really a caricature, because you'll see why in a minute, is that we don't really know if the sun will rise in the east tomorrow, because it hasn't happened yet. And maybe there's some general law of the universe that on a particular time, all the rules change. So obviously that's not very useful in the sense that there's no point in going around the world, or excuse me, we need some basic assumptions and beliefs about our world to make sense of it and operate within it. But that's but that in some sense, in a philosophical sense, is true. Now, in our reasoning, in our examples and settings that we explore in organizations and people and strategy, and for that matter, OB, we're in a much more, we're in a world where we're making much more contingent and bolder inferences than talking about where the sun's going to rise tomorrow. The third mode of inference, which is called abduction, which is related to David, Charles Peirce in the 1800s. And in the last 20 years or 30 years or so, there's been a huge amount of, or a considerable amount of work in the philosophy of science is inference to the best explanation or abduction. I'm equating the two here. If you delve into this literature, there are, they will argue, the philosophers will argue about differences between them. For our purposes, I don't think they really matter. So I'm not going to distinguish. And here's an example of abductive inference. Socrates is mortal. That's my data. All humans are mortal. That's my theory. Therefore, Socrates was a human. Right. So I've flipped it around. I'm going to provide you with another explanation related to what we just described earlier. Socrates, turns out your friend is Socrates. He didn't answer the doorbell. That's the data. People who are sleeping are less likely to answer doorbells. That's your theory. Therefore, Socrates is sleeping. So when I put it this way, it becomes very clear that this explanation, it's derived from theory, but it's not necessarily true. And it's obviously so because, of course, we understand that there's many possible explanations for why you might not answer the doorbell. And the reason is that IBE is itself is an inferential fallacy of affirming the consequent, right? So, which is to say that the conclusion may be false even when the premises are true. So, and if you were to write that down, Socrates, there's the consequent does not answer the doorbell. And then we have if P then Q, the P is they're sleeping, right? And therefore Socrates is sleeping, and you can see the circularity here, Q, therefore P. And that's a problem. However, this is how we reason in general. And so let me, it still works pretty well as we go through these explanations as we reason. I want to give you an example. I don't have the original picture, but many years ago, a friend of mine and we were traveling in Portugal just before grad school, and we saw two restaurants, and it was a little bit early, and they were both empty. And my friend said, watch, we're going to pick a restaurant. We have no idea which one is better, but after we pick it, everybody will go to that restaurant on the assumption that we picked it for a reason. And so we did that. We randomly chose one of the restaurants, and it turned out that his prediction was correct. And after an hour, our restaurant was full and the other one was not. But the reason is because everybody else thought that the people are in the restaurant because it's good, and then therefore they went to that restaurant. And so that was an error. It was an inference to the best explanation. It wasn't a terrible guess. They didn't have a better guess, right? And they acted on that guess, but nevertheless, it wasn't quite true. So with all that said, the next part of the talk is going to go through why this is almost always the best we can do and how to make it better. And the way I'm going to do that is I'm going to explore the framework that we commonly use, which is the hypothetical deductive framework. And I'm sure everybody, or I hope that everybody in the room is familiar with this, where you would select your hypotheses, and then what you do next is you evaluate if H naught, the null usually is likely given the data, right? And then you do this kind of Hail Mary, you hope, which I haven't even put here because it's not technically part of the framework. You hope, well, if I've eliminated H naught, I have H1, right? And H1 is likely true. Now, we all know that the rejecting the null does not mean that H1 is true, but nevertheless, that's what often happens in practice. So what does this look like? We have a test of not H1, a friend lost their hearing. And then there's multiple possible H's that could be true, right? And we listed them as explanations earlier in the talk. And the issue, one of the issues that commonly shows up in this framework is the identification critique, which is maybe there's some other theory that would produce the same data pattern. That is a really interesting topic. That's not today's topic. Right? So I just want to sweep that out of the way. And there's lots of work on that. That's not my topic today. I'm going to take a different angle. Right? And I'm going to point out that almost always this relies on frequency claims. So when we reject H naught, usually what we're doing is we're using some frequency statistic to make that judgment. A p-value, a confidence interval, it's based on a standard error, a t-statistic. These are all different and related ways to reject a null. And but the thing is that frequency statistics are general inductive statements, and I'll explain why in a heartbeat. Right? Oops, sorry about that. So here's an example, and so let's just think about for a second what the definition of a p-value actually is. Right? And it is and I'm just going to read it, is the expected frequency of estimating a statistic with a point value greater or equal to what you estimated, that's your beta hat, if the null hypothesis is true, right? And here's some additional conditions that are often ignored. In a repeat random sample drawn from the same population. Right, so we really need these two things, and the statement is only that, and nothing more. Right, I could go through. I'm not going to do it right now. I could go through the same exercise with a standard error or a confidence interval, and in each case, I need these conditions in red at the bottom.